Dear students, welcome back. In this video, I want to show you how can we solve a linear system by matrix method or inverse matrix method. In my previous lecture, I discussed how can we obtain A inverse. And we obtain A inverse by using this formula, adjoint of A divided by determinant of A, where A is a square matrix. And a square matrix A has inverse if determinant of A is not equal to 0 or if A is non-singular. When determinant of A equals 0 or A is singular, then we cannot calculate A inverse. Now in this video, I want to show you how can we use this inverse matrix method to solve. Now in this video, I want to show you how can we solve a system of linear equations by inverse matrix method. For example, let us consider a simple two variable system, 2x plus 3y equal to 8, 5x plus 9y equal to 23. Now I want to solve this system by matrix method or inverse matrix method. So I need to write this system in matrix form. Matrix form means you need to first write the coefficient matrix, coefficient of x 2, 5 and coefficient of y 3, 9. This is the coefficient matrix, and you need to put xy in the first column. Then this equal 823. This is also a column matrix. Now you can go back from here to here by just multiplying this. You see 2x plus 3y equal to 8. You will get first equation. And 5x plus 9y equal to 23. You will get the second equation. So a linear system we can write in matrix form like this. Now here we want to solve this system. It means we want to calculate x and y values, the solution. So let us denote this matrix, coefficient matrix, by A, and this column matrix by x, and this column matrix by capital B. Therefore our x that we want to calculate, capital X, will be A inverse B. A inverse B. Since from the left side, if you take A from left side and want to put it in the right side, it will move to the right side by A inverse, and it will keep its position. A is in the left position in the left side, so in the right side it will also keep its position. You see, A inverse is in the left of B, since A was in the left of X. So in the right side, A inverse will be in the left of B. This is important to note. So the solution we will obtain when we calculate A inverse and multiply it by B. And we know A inverse means adjoint of A divided by determinant of A. And for the 2 by 2 matrix, we can use a formula which is this. For A equal A, B, C, D, for this matrix, A inverse equal 1 by AD minus BC, which is determinant, and adjoint will be D minus B minus C A. We know this formula. Now the determinant of this A will be 2 into 9, which is 18, minus 5 into 3, which is 15. And the adjoint, in the adjoint, 2 and 9 will interchange. So I should put 9 here and 2 here. 3 will be here, but the sign will be opposite, minus 3. 5 will be minus 5. This is the inverse, and you need to multiply it by B, which is 823, and this equal 1 by 3, 9 minus 3 minus 5, 2, 8, 23. Now if you multiply two matrices, then this row and this column will be what? 9 into 8, which is 72, minus 3 into 23, which will be 69. And second row, this column, 5 into 8, minus 40, plus 2 into 23, which is 46. And this equal 1 by 3, 72 minus this, which is 3, and which is equal to 6. So if we multiply 3 by 1 by 3, we will get 1. If we multiply 6 by 1 by 3, we will get 2. So x means this and x means xy. Capital X means small x. So small x equal to 1 and y equal to 2. This is the solution of the given linear system. And this is called inverse matrix method. By using this method, we can solve a system of linear equation. Now let us look into a linear system having three variables. So in this case, your coefficient matrix will be a 3 by 3 matrix, and you need to calculate A inverse first to know the solution, then multiply the result by B. And A inverse we can calculate like the way we did in my previous lecture. You first need to calculate determinant of A, which will be 419, and then cofactors of each component of A will be what? For example, cofactor of 5 will be minus 1 to the power A11. Cofactor of 5 we denote by A11. So minus 1 to the power 1 plus 1, determinant of where 5 is located, you need to delete first row, first column. Then the remaining sub matrix is this 4 minus 3, 1, 6, which is equal plus 1 into 24 plus 3, which is equal 27. So A11 is equal to 27. And cofactor of minus 6, the same way you can calculate, which is minus 48. Cofactor of 4, A13 equal to negative 1. Cofactor of 7, A21 equal to 40. Cofactor of 4, A22, which is equal to 22. Cofactor of minus 3, A23, which is equal minus 17. Cofactor of 2, A31, which is 2. Cofactor of 1, A32, which is 43. Cofactor of 6, A33, which is 62. Let me calculate cofactor of 6, A33 for you here again. Minus 1 to the power 3 plus 3, determinant of, you need to delete this row and this column. Then 5 minus 6, 7, 4. 5 minus 6, 7, 4. This is equal minus 1 to the power 3 plus 3, which is plus 1, and 5 into 4, 20, plus 42, which is equal 62. So this is how you can calculate cofactors of each components. Now the adjoint of A will be the transpose of the cofactor matrix, which is this. And if you divide this result by the determinant, you will get A inverse. And A inverse into matrix B, you will get the solution. But note that you need to keep this part here before multiplication. আপনাকে আগে মাল্টিপ্লিকেশনটা শেষ করতে হবে, তারপর 1/49 দিয়ে গুণ করতে হবে। কিন্তু আপনি যদি আগে 1/49 দিয়ে গুণ করেন, then the calculation will be a bit difficult. So first you need to multiply this row, this column, and the result you will obtain from here, you need to divide by 419, then you will get 3. Then second row, this column, the product of this row, this column, you will obtain the result from here, you need to divide by 419, you will get 6. Similarly, by the multiplication of this row and this column, you will get a result, you need to divide it by 419, you will get 6. So the solution of the given system is this 3, 4, 6. This is how you can solve other linear system. In this video I show you a 2 variable case, a linear system of 2 variables and a linear system having 3 variables. Similarly, you can try these problems in your apartment to solve by inverse matrix method. Here first you need to calculate A inverse, then solve this system. It means you see the coefficient matrix of this system is exactly this matrix. So when you will calculate A inverse of this matrix, you will use this result to solve this linear system. Similarly here, first you need to calculate inverse of this matrix, and the coefficient matrix of this linear system is this one. So you can use the previous result in order to solve this problem. Similarly, you can try these problems in your apartment. That's all in this video. In my next video, I will discuss some application of matrices. Thank you very much for your watching.